Okay, YouTube, in this video we're going to be writing transformations of functions, and most especially translation and reflection transformations, given some parent function f of x and what we know about these transformations. So let's go ahead and start here. It says in the opening activity we saw how adding or subtracting or multiplying a function f of x by constants changes or transforms the graph of the parent function. So we say that these transformations that we've observed are as follows. We've seen vertical and horizontal translations as well as reflections. So in this sort of module here, we're going to learn how to write functions that represent translations and reflections, and then in future videos we'll talk about vertical and horizontal stretching and shrinking, as well as writing functions that have combinations of such transformations. But again, we're going to start with translation and reflection transformations, most especially translation transformations here. So what we learned in the first exploration that you should have done at this point, we say that the graph of y equals f of x. If this is our parent function, y equals some f of x here, we learned that if we were to add or subtract some k value onto here, what we're really causing to have happen is some vertical translation. In other words, we're taking all the y values and we're adding or subtracting some constant off of them. It just causes our graph to shift up and down. So that's what this is going to say here. It says the graph of y equals f of x plus k is a vertical translation of the graph of y equals just f of x, where it's just the plain parent function, and we don't allow k to be 0. So things I want to point out here, we say if we have y as some function of x, so some parent function where we've added on k and k is positive, you'll notice that what we're causing to have happen here is it shifts up exactly k units. Whereas if we had some parent function y equals f of x and we were to add on k now, but k is negative, in other words, we're subtracting off of k to all of the outputs on the function f of x, then we say it's going to shift down exactly k units. And then the other type of transformation we had seen was a horizontal translation, or a horizontal shift, where if we had some y equals f of x and we were to either add on or subtract off some h value there, or some constant in here, we would see some horizontal shift. Okay, so what this says here, it says y equals f of x minus h is going to shift left if h is negative and shift right if h is positive, if we have some minus h in here. The thing I kind of want to point out is this. This is a little bit backwards. If h were to be some negative value, and this is just a hypothetical here, say h is negative 7. The thing is, when you plug in a negative 7 here, you're subtracting off a negative 7 using this minus sign here. And what that causes to have this happen is it switches to look like a positive 7. It looks like a positive 7. So if this were a negative 7 in here, it actually shifts 7 to the right. If it's a positive 7, it shifts 7 to the left. What I'm going to do is modify this definition a little bit. And I think that the best thing we could all do for ourselves here is this. We're going to write f of x plus h. Okay. We're going to write a plus here as well and a plus here as well. And then we're going to say this. If h is positive, in this case, if it looks like there's a plus in here, it's going to shift left. And if h is negative, okay, it's going to shift right. So in other words, we're going to say that this inner value, this h value here, is backwards. So if it's positive, it actually shifts left. If it's negative, it's going to shift right. So let's take a look at a few examples. What we're going to do is be writing translations and reflections of functions, starting with translations. Excuse me. And it says, first of all, let's let our function f of x be this 4x minus 9, this function that's in the linear family of functions. And what we want to do is really write a function g, some new function, but g is just the same graph as f of x, but translated 5 units up from the graph of f. So when we write this, we want to say, well, g of x is the same as f of x, but it's translated 5 units up. So let's use what we know about vertical translations. Vertical translation would just be the original function, whatever that was, and in this case it's f of x, and we're just going to add on 5 to that. So we'd say whatever g of x is, it's our original function f of x, and we're adding on 5. In other words, g of x is really just f of x translated up 5. At this point, though, what we're going to do is we're just going to perform a substitution. That is, we know that f of x is the same thing as 4x minus 9. So if we're going to rewrite this again, we'd say, well, then g of x, instead of writing f of x plus 5, we know it's the original function plus 5 on all of its y values here. We're going to say, well, I know f of x is 4x minus 9. And at this point, we're just going to combine like terms and simplify this function. So we get 4x minus 9 plus 5. Well, the negative 9 and the positive 5 combine like terms to be a negative 4. So we get 4x minus 4. Okay. And then in this next one here, it says write a function h whose graph is a translation 1 unit to the right of the graph of f. Now this is where we're going to get into the fact that horizontal translations are kind of a little bit backwards here than what you would expect. But we say, okay, so what we know is that we have some function here, h of x. And I know that it is translated 1 unit to the right of the graph of f. Now, translating left and right, we're saying that the constant we're adding in is inside the parentheses here with the x, okay? Whereas on the vertical translation, we were adding some constant to the outside of the function to all the y values. We're adding or subtracting some constant to all of the x values. So we're going to say h of x really is the same as f of x, but we're translating it 1 unit to the right. So I'm going to actually, since it's backwards, subtract 1 off of all of the x values. We're going to shift it backwards here. It's 1 right, but notice we're adding that constant onto the x value here. So if this is the case, then again, we're going to perform a substitution. Now what we know about f of x is 4x minus 9. So in this case, we're going to say h of x is really f of x minus 1. Well, f of x minus 1 just means wherever we see an x, we're going to go substitute this in. So 4x minus 9, we're going to take the x out and input x minus 1. And simplifying this expression here, we really come up with this new function, 4 times x minus 1 minus 9. While distributing, we get 4x minus 4 minus 9. And when we simplify this here with our negative 4 and our negative 9, we actually get 4x minus 13. And this would be some new function that really is just the same as the original function, but it's translated 1 unit to the right. Okay, so now let's confront reflections. Okay, what do we know about reflections? Well, we have 2 types of reflections. Reflections that occur over the x-axis and reflections that occur over the y-axis, okay? And I basically just want to generalize these here, but if you had a point, say xy in the coordinate plane, we'll call this some point xy, and you wanted to reflect it over, say, the y-axis here, it would appear over here now, but let's consider the fact that if I were to rewrite the coordinates, really all we would notice is that the only thing that changed is that the x value would be the opposite of what it is that we started with, okay? Whereas if we were to reflect this now over the x-axis, it would be down here, and in terms of its coordinates, the x value would be the same, but the y value would be opposite. So to put this generally, we'd say the graph of y equals negative f of x is a reflection in the x-axis of the graph of y equals f of x. In other words, if we wanted to reflect this over the x-axis, what we notice is if the original function is just plain y equals f of x, where f of x is the same as y, we'll just put a negative in front of all the y values here, and it should flip over the x-axis. Likewise, we say the graph of y equals f of negative x. Now you notice what we're making negative here. We're making all of the x values negative. If the original function is f of positive x, if you were to plug in negative x values, again, look at this, we would say that a negative x or an opposite x would reflect it over the y-axis. So we say y equals f of negative x is a reflection in the y-axis of this graph right here. So in other words, if you multiply all the inputs or the x values by negative 1, it's going to change their sign and reflect over the y-axis. In other words, making x is negative, it reflects it over the y. And over here, multiplying the outputs of the y values by negative 1 changes their sign. In other words, if you want to reflect it over the x-axis, you make all the y values negative. It's kind of a backwards thing. Make y negative, reflects over the x. Make x negative, reflects over the y. So let's take a look at this here. It says writing reflections of functions. And we have some function here, f of x, and it seems to be in the absolute value family of functions. It says what we want to do here is take this f of x, and in the first example, write a new function h, whose graph is a reflection in the x-axis of the graph of f. So really what we're going to say is we have some new function h of x, and we want it to be the same as f of x, but we're going to reflect it over the x-axis of the graph of f. So what we know is if we want to reflect it over the x-axis, okay, reflect over the x, we're going to take all the y values and make them negative. In other words, we're going to make f of x, its y values negative. At this point, though, all we need to do is just run a substitution. Again, we know what f of x is. F of x is this absolute value of x minus 5, that minus 4. So I'm just going to go ahead and substitute this in. We have x minus 5 minus 4. And if we were to distribute now this negative throughout, we would get some new function that says negative the absolute value of x minus 5. Remember, we can't distribute this negative through the absolute value bars. They're not parentheses. They actually behave a little bit differently here. And then a negative distributed to the negative 4 here makes us a positive 4. Okay. Whereas down here, let's take a look at this example. It says write a function g whose graph is a reflection in the y-axis of f. So we have some function g of x. And since we want it to be a reflection in the y-axis of f, what we're going to do is we're going to take f of x we're going to make all of its x values negative. Again, consider this example up here. If we want to reflect it over the y, we're going to take the x values initially and make them the opposite of what they were before. So we're going to say, let's take the x and make it negative. So now, running a substitution on this, we have g of x is equal to f of negative x. Now I know what f of x is. F of x is this x minus 5, the absolute value of that, minus 4. We're going to go plug in a negative x wherever we see an x. And I had that one right there. Okay. And here's my initial function where I've taken out the initial input, and now what we're substituting in is this negative x. So what we get is this absolute value of negative x minus 5, that minus 4. This is going to be some new function that actually reflects over the y-axis since we made the x value negative, okay? Excuse me. So in this last example here, basically what I want to do is kind of the same thing we just did, putting all of these together, but we're also going to use a graphing calculator to check our answers here. So I am going to get my graphing calculator out. Here it is. And I'm going to turn the contrast up a little bit here. But essentially, go ahead and take a look at that first example there. We want to write some new function here. And in this case, all of our original functions are different. But it seems like we have some f of x that is 2x. And what we want to do is write some new function g who satisfies this right here. So we say I want to translate it 4 units down. Okay. So remember that vertical translations are going to occur when we take all the initial x values, or y values, excuse me, and we add or subtract some constant onto or off of them. So we say that if f of x is 2x, we want some new function g of x that is the same as f of x. It's the same thing, but we want to translate it 4 units down. So we're going to subtract 4 off of this. And again, we're going to just run a substitution here. We know what f of x is. F of x is just 2x. So g of x should be this 2x minus 4. Well, using our graphing calculator, let's take a look at this here. Our initial function, we'll go to y equals here, and we're going to type in 2 times x. I'll hit graph. And so we see this linear function here that is a little bit vertically stretched, but we say 2x here. What we're going to do now is go back into y equals, and I'll type in for y2, we'll say, well, 2x minus 4. And what we should see is this translation of our initial graph down 4 units. We got 1, 2, 3, 4, and we can see that it's got the same slope. They're parallel, but it has been shifted down 4 units, okay? So now taking a look at this next example, we say in the next one here, we have f of x is this absolute value of x plus 2. What we want to do is translate this 3 units to the left. So again, recall when we talk about left and right translations, we're talking about something that looks like this, some inner constant that's being added or subtracted to the x values, not the y values, but the x values inside here. So if we want to translate this 3 units to the left, and keeping in mind that this is a little bit backwards, okay, we want to go 3 left, we're going to have to put a negative 3 in here. We should say that we get some new function g of x, and if it's going to be translated 3 units left, we're going to say, well, let's take the x values, and we'll actually subtract 3 off of them. So again, what we need to do here is our substitution. We say, well, what is f of x minus 3? Well, f of x is this. So f of x minus 3 would be, plugging in for x here, we would substitute in the x minus 3. So we would get the absolute value of x minus 3, that plus 2. Now, putting this into a graphing calculator, this isn't hard, but we're going to have to take a separate approach here. In order to get absolute value, we're going to head down to this yellow word here. It says catalog. So we say, okay, well, what I want first of all was the original function, which was the absolute value of x plus 2. So we're going to go to catalog. The very first option here says ABS, absolute value. We're going to say ABS x, and again, I'll hit graph here. You can see that this is our initial parent function of the absolute value function. And as a matter of fact, I've forgotten something here. We had absolute value of x plus 2. This will show you something as well. That's just actually just shifted up twice from our initial parent function. But anyways, here's our original function f of x. What we wanted to do was shift it 3 units to the left. As a matter of fact, since we're going left here, I noticed that I have a mistake. Since it's backwards, this is going to have to be a positive 3. My bad, my bad. But let's go ahead and go back into y equals. And then this time, we're going to go to our catalog. We're going to say the absolute value. We'll click on that here. We have x plus 3. That should actually take it left 3. And then we're going to add 2 to this. It's this new function here. And looking at it, we can see that it's the same function we had initially, but it shifted 3 units to the left. Okay. So now let's take a look at this function down here, these two. We have f of x equals this negative, and then the absolute value of x plus 1 plus 3. What we want to do is reflect this over the x-axis. Now recall, when you want to take an initial function, some f of x, and reflect it in the x-axis, what we're going to do is take all the y values, these f of x values, we're going to make them negative. We're going to make them opposite. So what we get is some new function here, g of x. We say g of x, if I want to reflect it over the x-axis, is just opposite the initial y values. That's all we're going to do. So now, again, using a substitution, we say, well, I know what f of x is. F of x is negative absolute value, x plus 1, plus 3. That's the thing right here. And we're just going to distribute this negative throughout. So when we do that, we get negative out front, which makes this a positive absolute value of x plus 1. And we get negative positive 3, which is a negative 3. So in this case, we get this new function here, and we'll go take a look at its graph. So here we go, graphing calculator. We're going to y equals. We'll clear these out. So up to y1 here. So our initial function, f of x, is this negative, so negative key here. And then we got to go into our catalog to get out the absolute value. Negative absolute value of x plus 1, that plus 3. So here is our initial function that seems to be the absolute value graph that is opening down. Looks like it's shifted left 1, up 3. Let's take this, and what we wanted to do is reflect it over the x-axis. So going back into y equals, well, we already found a function for this. We said, well, it'd be positive absolute value of x plus 1, that minus 3. So let's go ahead and go into our catalog. We don't need to put a positive out front. It already is positive, and we say x plus 1. So we have x plus 1, and that minus 3. We should see here that we get the same function that has indeed reflected over the x-axis. So now for this last one, I would encourage you to give it a shot here before I type it in. You could just pause the video, but let's take a look at it. We have some f of x here. It looks like a linear family of functions here. But it says we want to reflect this over the y-axis. So last but not least, we say, well, if you want to reflect some function here, y equals f of x over the y-axis. Remember, what we're going to do is we're actually going to take all the x values and make them opposite. We're going to take that and do that. So we say that I get some new function, g of x. And in terms of f of x, if I want it over the y-axis, we're just going to say f of negative x. So now let's go ahead and find what f of negative x would be. Well, we say that f of x is 2/3 positive x plus 2. Well, now we have 2/3. We're substituting something in for x. We say plus 2. And we're substituting in a negative x wherever we see an x. So in this case, we really just get negative 2/3 x plus 2. And so we'll look at this on the calculator. And our initial function here, we'll type it in. So to type into the 2/3, we actually want a parenthesis, and then we'll just hit 2 divided by 3. And say x. And we had plus 2. And then our next function here, we have negative parenthesis 2 divided by 3, x, and we have plus 2. So looking at this, I'll hit graph here, I'll hit enter so it stops. So here's our initial function. I've paused it. We have a slope of 2/3 and a y-intercept of 2, but this linear thing we're going to reflect over the y-axis. By making that x value negative, you can see that it actually reflected all the x values over the y-axis here. So these are our basic translation and reflection transformations. In the next video, we'll take a look at stretching. Cheers.